Okay, good morning, everyone. Good morning. Let me open the chat. Wait. Here, this one. Let me open the chat. Okay. And I have to go here. Let me open right chat because I was watching at the previous one. Here. Live. Fantastic. Ooh, it takes forever to find the videos. Oh, finally the chat. And I can close this. Good morning everyone. Good morning. Okay, so before we start, as usual, in the meantime, I have to open Inventor, maybe. So, as I was saying, as usual, do you have questions, doubts, things that you want to ask me, or whatever, Inventor or in general school related doubts, how to do this, how to do that, something like this, or not? The answer is maybe not. No doubt, nothing. Really? Let me also check if live streaming is going. Yes. It is perfect. Okay. No questions. Great. And just a quick question that is, how about your final project? Have you started? Have you finished it? Have you are you developing something for the final project, something that you want to share with me, something you want to ask me something about the final project? Tell me. Or zero, nothing. Still on inspiration mode. Still on inspiration mode. If you Google and you go Google Translate and you translate still on inspiration mode, you will see that it is translated into I haven't done anything because I'm lazy. If you Google it, when you have something that you want to share with me, like a PDF, a mood board, a presentation, something that that is the thing that you would like to develop as a final project, you have to simply place it Exactly. No, mood board is fine. Place it into the same folder where you put all of your homeworks. No? Let me just find it again. There is Inventor. So Inventor midterm, no. Inventor homeworks. This one. So share. Exactly. Sharing permissions are fine. Just in case, I paste it here, and I simply suggest, but I thought, like I did for all other classes, when I give you this link and you open it once, just be so nice to bookmark it like this, so that it will stay in your bookmarks, and you have not all the times to look for these folders, search it, to remember it, asking mail me, and so on, so on. Now I will remove it because I know it. Okay. So if you upload your mood boards, and if you just send me a message saying, Marco, I have uploaded, at least I can start having an idea of which kind of projects you would like to develop in these last 4 weeks, yes, so that I can give you hints, I can show you things that are more oriented on certain specific projects, certain specific shapes, and so on and so on. Okay? Is that clear? Let me. There is a cable here, the headphone. How annoying it is. Perfect. It's not that perfect. There is something that is pulling headphone cable, and finally. Okay. So let's see what. Great. So then I will have a look at this file, and then I will see if I can show you something that is more specific for the type of project that you would like to do. So I just wait all of your other classmate mood boards as well, so that maybe next week we'll do something that is like how to do this, how to do that, by taking inspiration from your mood boards. Today we have to see instead a lot of very complex things, a lot of things, and we need to start really going in depth in modeling complex shapes, because till now we know a lot of tools already, but we can do even more. We can make even more complex, but not just for the pleasure of making complex things, but maybe because sometimes something that happens very often in Inventor is that we may have an idea, but then we don't know how to translate our idea into an Inventor file, and so this sometimes becomes a limit, and a lot of students, a lot of professionals in general, tends to simplify their projects because they maybe don't know certain aspects of the software that they are using. So today I want to show you, first of all, something that we have already seen, that is loft, but I want to add something a little bit more interesting. That is, I want to show you how to use also guidelines into Loft. Then we will then I will show you just a couple of interesting features that you can find into the 2D sketch that we haven't already explored. Then I will show you one way to draw shapes in Inventor that is extremely interesting, but as well a little bit complex. That is, we have to see, by clicking here, we have to see something that is called the 3D sketch. We have also to see, but I mean, the menu is very, very full of stuff today. We have also to see patterns. So we have to see at least a circular pattern and a rectangular pattern in order to make parametric repetitions of our object. And I will show you that there is a little bit of different when you see pattern into the 3D model, but then you will see also patterns into the sketch. So, I mean, there are a lot of things that we have to study. Let's start with what is, from my point of view, one of the easier topic for today. That is, I want to show you a few more tools into sketch, into 2D sketch. So, for example, I just select a plane, let's say XY. I click Start 2D sketch, and as usual, I have my common tools. I have line, I have circle, I have arc, rectangle, fillet, and so on and so on. But first of all, I want to show that whenever you have a tool and below this tool there is a triangular button, you need to know that there are hidden tools inside that particular starting object. So below line you can find spline with these two ways. You can find also bridge. That is an interesting tool because it basically smooths two curves that you have previously created. There is also this one that I will never explain. There is equation curve. So if you have a function like x plus y plus n equal to etc., etc., you can create a curve by having a given function. So first of all, you need to know that, I mean, we can just draw lines like this. But what is interesting is that it is a function that is really hidden somewhere, but in when we sketch, for example, underneath rectangle, there are a lot of additional tools. There are even 4 in general ways to create a rectangle. The one that we use is only rectangle between 2 points, and basically we just click on a vertex and then we click on the opposite vertex. But there is also rectangle between 3 points. That means we can make our first click, our second click, and it can be wherever. So we are not even limited in making always straight rectangles. But if we make this line, for example, then third point that we click will start from that edge, and we will make directly a rectangle that has a certain kind of rotation. This certain kind of rotation at the very beginning looks like something that you have to manage only after creating your rectangle. While it's not true, because whenever we draw something, that can be a line, that can be a rectangle, but something where we are free to choose the direction, we need to see this. Look, you can see that when I draw and I move my mouse into my viewport, basically, I can see that there are these two numeric fields that are appearing, and they are showing me x and y, because I'm in xy plane, xy position of my mouse. So if sorry, I forgot to open my software for the pen, but why I want to show you this? Simply because axes that we see when we draw, so these two axes are main axes of our drawing plane. So this is the x, this is the y, and according to the way that we see the orientation of our viewport, this point in here is the origin, so it is 0 point. And this side is the positive side of our x-axis. This is positive side of our y-axis, so that these are negative sides of our axis. So when we draw and we see a certain number that is like +2, -3, it means that we are, with our mouse, +2, and first value is x. -3 means that we are here. This is -3 for the y. So we are in this position with our mouse. And those numbers can be just read from the screen, but we can also type things inside those fields. We just need to know how exactly this happens. So let me show you. That is very simple. That is this. When I make a line, let's say I want to be sure, even if I can snap the origin, but sometimes if I just move a little bit my mouse, I can see that by just making a very small movement, sometimes I'm not super precise. But what I can do is, when I draw something and I see these white numeric fields appearing, what I can do is I can immediately press a number. Okay, no. Oops. So I press, sorry, I can't immediately press the number, but I have to press Tab on the keyboard, and when I press Tab, one numeric field, instead of remaining white, becomes blue. And if the numeric field is blue, it means that I can edit. So if I press Tab and the X becomes blue, now I can write. And I basically lock the fact that my line will start from a coordinate that has x equal to 0. When I want to switch to my next numeric field, again I have to press Tab on my keyboard. Inventor shows me that the X has been locked, and you can see that my yellow dot is locked on remaining on my 0 X position, so it slides up and down on these axes. But again, if I just want to be sure that my line starts from the origin, so from that point that has 0, 0 coordinate, I press Tab, I type 0 again, and then I press Enter. Boom! And my line starts exactly from the origin of my plane. And this particular way to draw is not only in order to lock x and y coordinates, because when I start my line, for example, I can see that first point is something that Inventor manages in XY coordinate system, but then when I want to make my second point of my line, Inventor gives me two other parameters that are length, that is the one that I can immediately type, and by moving my mouse I can see that second parameter that is written there is also with the units that is written degrees. That is the direction. But even here, if I want, I can lock and be more precise when I draw my shapes. So if I want to be sure that my line is 45 degrees, what I will do is I will press Tab. And I go to my second numeric field, and for example, I will type 45. Then, if I don't press anything, I can just press Tab again to go into the length. The angle has been locked. Okay, and you can see that I can't go down here, because down here it won't be 45, but it will be 305 degrees. It will be 45, 90, 180, sorry, it will be 225 degrees, this direction. And now I have basically two choices. Or I even type my length. So let's say I will make it 30 millimeters and I press enter. Or I just set the angle, for example, this, and this is the trick. I press 45 and it is horizontal. And this is weird because you may think that this will be 180 degrees, but you need to see from where it starts counting. So this is 45 degrees from my previous segment, not in general from the XY coordinate. So I can even just click the length and then I will make it vertical and so on and so on. But this is to show you that you can be extremely precise even from the beginning of your drawing. So I can type 10, then tab, and I can say 135, tab, and I will make this line in here, and then I press enter. And I can make very precise shapes from the beginning. And this is true whenever you have tools that allow you to manage numbers. So even when I make this kind of rectangle, you can see that first point is in X and Y. So I will make it like here. But then, in order to set length and angle of my rectangle, Inventor asks me length and direction. So for example, I will make length 20, tab, I will make 45 for direction, tab, and this is how my first side of the rectangle is going to be. Then I press enter and I make my second element. Let's say I make it 20 again, so that I have made a perfect square that is also immediately 45 degrees angled. But there are more tools in here. So there is rectangle from center and point. There are also all of these beautiful tools. There are called slot. They are extremely useful when you want to make joineries between pieces in your assembly. This is because these shapes called slot that can be made in a slightly different way. I mean, final shape would be exactly the same. It is only that you need to just choose if you want to draw them, if you want to take 3 points, if you want to make a center point. I mean, there are different ways to design slot. Let me show them. So first one is very simple. It is you pick one point, you pick another point, and with your third click you basically choose thickness of this shape in here. You can use another way that is called overall. So you pick from where this slot begins till where the slot ends. So instead of taking the center of those circles, you take extreme points of this particular shape. And again, with your third click, you specify how thick the slot is going to be. You can also have slot from the center. So you start and your first point would be middle point. So it would be symmetrical from that point. And it can be curvy. So you can take this slot and instead of making it linear, you can make it curvy by drawing an arc between 3 points. And then again, you will use your last click to give the thickness, or you can make same thing by making from where the slot starts, but instead of using 3 points, you set the center of your arc, and then with the second click and third click, you create the path of these, and last, you select thickness. Okay? This shape here is extremely common into woodwork because this is a very simple kind of shape that can be obtained by using basic tools. In general, this is something that it starts in. It can be made in two ways. It can be made as a male or female connection, and let me show you. Let's say you have this box. Just make it taller. Okay. And you should make it into an assembly, but I'm just showing you the feature. I make another box, and I want to make a box in this plane here. But most important, I want to treat these two elements like two unrelated things, so I will use new solid so that they are not joined together. There is nothing in common. But just to show you this, when in woodworking you want to basically join this with this, and you want to make a 90 degrees angle, beside the fact that there are a lot of ways to do it, one for sure way to do it is to create slots, because there is a tool that is called router, that is basically like a drilling bits, but so like a drilling machine, but instead of having the drill bit that goes in along the axis of its shape, the drill bit cuts from his borders, from his edges, and for example, you can easily make this. You can make like a 2D sketch on this face, and you can make a slot in here. I will just to remember dimensions, so I will type 5, enter, and I will make it 2, enter, and I will make this as a negative extrusion, so I will click extrude. I will go on the opposite direction, and let's say I will make not 48 is too much, let's say 5. Okay, so I create this element here, and in this other piece instead I will create a sketch in here, I will make same exact slot dimensions, so it was 5 and it was 2, but in this case I will finish the sketch. In this case I will make a common positive extrusion, boom. Now don't mind the fact that this is just one component, but if they were just 2 components, they can be used into an assembly, because this male connection here will perfectly fit this female connection in here, and I have 90 degrees connected wooden parts. So this is why slot is very common, and also in the real world it is highly used. Okay, till here? Because into the sketch there are a few more things that I want to show you. There are, into the sketch, last few things that we need to see are: thing number 1, below slot there is also, and it is hidden underneath rectangle, there is also polygon. So if we want to create regular polygons, we can do it, and I mean, it is too simple. We have also the possibility to create inscribed or circumscribed polygons according to which dimensions we know. We can change here number of edges that our polygons will have. Let's say I make 7, and then I click and I make my beautiful boom polygon. Okay, and I can make it, as I said, inscribed, circumscribed. That would be like this. Boom. And I can easily make regular polygons just without trying to draw them one line by one line and so on, while I can easily use this tool that is called polygon. Okay? Till here? Tell me something. Till this tool? Yes? No? Maybe? It looks like it is maybe. Great! So, look why I've done also this particular shape. When I make a shape like this, or a circle, or I can just draw a point in general into my sketch, and the point is an object that has no dimensions, it's just a point that I can snap. But I want to show you this because, for example, now I can make an arc, and I can make an arc like this. Look, from here to here, and I can set my third point on this snap. And what I would like to do is, I would like to repeat these arcs in all these other triangular parts. There are 1, 2, 3, 4, 5, 6, and with these they are 7, just because I was starting from a 7-sided polygon. But I mean, I have a life beyond Inventor, so I don't want to make another arc, another arc, another arc, and so on and so on. While there is something called pattern here into my sketch. Take care, these are into the sketch tool. So I can find the circular pattern. What it means, circular pattern, basically is, in many other software, is called like array. And the one that is circular means that you can set a point, and starting from that point, the software will create the number of duplicates that you want with a rotation in between them. So what I have to do first is I have to click circular pattern. By being sure that I see geometry highlighted, I select the shape that I want to duplicate, and then I click this button here to select the center of my rotation. Once that I have selected these two things, so the geometry and the center, nothing else remains than that setting how many repetitions I want and how many degrees my repetitions need to cover. What is important is that the number that you see written here includes your starting object. So this is slightly different than, for example, 3ds Max. We have seen this in 3ds Max, if you remember. It is when we select an object, and when we click on Shift and Rotate. It is exactly the same thing. But in 3ds Max, we start by having our original object. If we want at the end 7 rotated objects, we have to type 6, because 3ds Max adds those elements. In Inventor, instead, the number includes your starting one. So if I want to make a complete circle, and I want to be sure that my objects are perfectly touching each other, I need to say that I want 7 duplicates, and these 7 duplicates are covering 360 degrees of rotation. Just to show you, if I make 180, they will make 180 degrees, and there will be 7 total duplicates. I can use this button instead, that is called flip, if I want a clockwise or an anti-clockwise rotation. Okay? In my case, I really want 360, 7 object. I click OK. Boom! And I have made this very complex shape in a matter of seconds. If I want now, I could delete all these elements, but in order to avoid deleting, just to remember, if you don't want, let's say, to extrude this one, what you can do is just select them and then click this option up here that is construction. So they become thin, visible elements, and they won't be considered when you make your solid transformation. So I can click OK. I have this kind of flower looking thing, and if I extrude, I will, oops, no. Yes, like this. Why? I mean, it should be perfect. Sketch. Extrude. No, I don't know why it doesn't like. Because they are perfect. No, it's okay. So, you know what? Just delete all these construction things. And, oops. Just delete them. Because, let me see if this was, if Inventor doesn't like these construction lines. Okay, let's see. Finish. Extrude. No, doesn't like them. I don't know why, honestly. Should be, I don't know if they are not touching for a very small part. They shouldn't. Let's see if I chamfer them or fillet. Oh, chamfer. Anyway, this is, no. Or Inventor is just stuck, probably. Probably yes. Ah, that's easier. It was crashing. Okay, sorry. Sorry, this is not my fault. But Inventor was stuck. So, this is, so let me continue with pattern. So, this is a tool that you find into Sketch. Sometimes you find already the center because you are using a circle, but let's say you have these. Let's make a pentagon. Okay. And then I draw my pentagon just somewhere. And I want to make, done, other pentagons all around this one. So sometimes I have not already a circular or a shape with a center. So when I have no additional geometries in Inventor, I can create point to make my circular pattern. So I will make a point by moving my mouse over here and by going down, so that at least it will be aligned with my midpoint. And the point is, it's not that visible, but it is just this dashed thing in here. So I can still use the circular pattern by simply selecting the geometry first. Then I have to click the center and I can pick my point. And I can again create as many duplicates I want. Let's say I want to try to make 8 of these. So that they have those intersections. Click OK. I can see that these shapes are intersecting each other. So let's see if I can use trim to cut these parts. And it happens that if you see, you can't trim them. Okay? And this is weird because this is happening only because this is a circular pattern. So what happens is that it is basically something that if you modify one of these, it will keep modifying all of your objects. Okay? And I forgot, so this is why the previous shape wasn't working. But if you want to now start from here and make a sketch by removing this possibility, because you now want to maybe trim all these lines and being able to make a shape that you can extrude, you need to, where is? You need simply to do where is. Okay, this we know. Okay, you have to do this. You finish your sketch, and one interesting but slightly complex thing that you can do is you can make a new sketch on the same plane, and you can simply project all this geometry on a new sketch, and you will project only those that you really need. Maybe I already did this. Okay, I finished the sketch. And if I hide my first one, so I right click or I delete it or I just change the visibility, this is the copy of projected edges that I have created in my second sketch. I will edit this one and I will try if I can trim it. And again, you can do it, but if you select your projected edges and you remove the constraint, so you select them and you right click on the constraint and you click delete, you will see that delete the constraint. So here, delete the constraint. You will see that the thing delete the constraint here. delete. Oh, here. Oh, how lucky I am. Nothing. I mean, just do it, try by yourself, and then, yes, finally, you will be able to trim them and to make a shape that you can extrude it. As you can see, I'm showing you this because, honestly, using patterns into the sketch is extremely complex and particularly annoying. Why I'm explaining this? Simply because look at these slightly different methods to create the exact same shape that I wanted to create. So something that starts from a pentagon that is rotated. Look, I will delete all these shapes and I will make something that is a lot easier as well as a lot more productive. Look, I select the plane, I make a sketch, I make my single polygon. Let's say it was like this, and I do one interesting thing, that is I close the sketch. I close the sketch and I make this becoming immediately a three-dimensional tool. So I extrude it and whatever side I want, and I make this like that. Okay? Ready for this? Now check this. On a perpendicular plane, so not on the same plane where I have drawn my pentagon, I select another plane, and what I do is I draw one sketch that will be just one line. And I'm making it vertical because I want this to become an axis for my circular pattern. So I make this vertical line here. I click finish. And what I do is, before doing anything else, I show you another tool that is placed next to plane, and it is this simple tool here that is called work axis. Work axis allow me to create axes from existing geometries. So I will click here and I will click on the line, and I will see now this new element that is called work axis. Also because axes like planes are invisible, so I can even hide my line. And now check this. By being into the 3D model tab, I can see that even here I see patterns, and into the specific I'm showing you the circular pattern. But what will be great will be that by making it now my pattern, instead of multiplying the sketch, being one sketch becoming one, no, I click circular pattern, I click the feature, so the entire solid that I want to rotate, and then I click rotation axis, and I can select these axes that I have created before. So in this way instead of creating one sketch that already has the shape that I want, I make one little piece, and then I said I wanted 8 of these. I click OK, and boom, and I have the shape that I wanted to create. And what is phenomenal is that I can see that my axis remains there. So if I want to modify something, like, see this, I select this face of my pentagon and I extrude it, and I extrude this shape. Look. And I extrude it with a certain value. So it goes till here, so that this becomes basically a hole in my simple 3D object. If I change my mind now and I say, no, now I have one hole in this side, but it would be great if I have same hole in all other objects, where's the problem? I make another circular pattern. I select the feature that is basically an empty cylinder. I select the axis, and by having that axis always there is perfect because they will share the exact same center. My holes were 8, so I click 8, I click OK, boom, and I have same feature repeated all over my objects. And I can keep doing these. So let's say I select this plane, I make another extrusion, I create a 2D sketch, and I create, I don't know, something here. It has to be just a closed shape. Perfect. I extrude this other shape from on the opposite side so that it will cut my final result. And because I'm not that happy, I click circular pattern, select this feature, select this axis, and I will click 8 objects, click OK, boom, and I have same cut repeated all along my objects. Okay? Till here? Let me know. Yes? No? Maybe? Perfect. So, if we get these, what we can do now is, look, I mean, this is not really important, but for example, I could select this plane, and you can see that working with precision starts by being extremely important. So you can see that my axis actually is also contained in one of my vertical plane, Why I want to do this? Simply because it is not really important, but it's just interesting. I will make a sketch in... no, it's true. I want to make a sketch in this plane. And, for example, I will go to View. I will change the visual style to wireframe so that I can see in transparency. And in my sketch, I will draw something like this. Why not? I click OK. And then I make a line to close this pattern here. And I finish the sketch. I can go back to my view, visual style, shaded with edge, just to show you that having that access is something crucial, because I can also use revolve, and when I select the axis I can still use this axis here, so that I make a rotation of my shape around the axis. For sure I won't do a join because it will cover that masterpiece that I've made. I will use that particular shape to cut what I have created before. So I click cut, I click OK, and after all these steps I was able to create this very complex looking shape that is rounded on top and on the bottom. It has 8 repetitions. I can keep adding features and features. For example, now I could fill it, probably. Let's select a loop. Let's see if I can fill it. This loop. Maybe 0.5. 0.3 maybe. Okay, so let's say I want to fillet these. I want to fillet that. I want to fillet this one. So I'm making a lot of fillet combinations. And again, it takes forever if I have to repeat these fillet options for all my available edges. No! I selected the wrong one. 0.15. No, I have to select just that one I shouldn't select. Okay, so quickly. So I want to show you that in general, pattern is something that duplicate features. But what you need to realize is that features in Inventor are not only shapes. If I'm using fillet, look, I'm using fillet in one part of my shape, and I click OK. So if I want to give same fillet to all other parts, again I can still use pattern. I will select the feature directly from the menu, or these, that is faster. I select the axis. Boom! I say, take care, you can see that now if I keep 6, the result will be wrong. There has to be always with a meaning. I click 8, I click OK. If Inventor doesn't crash, I knew it, but I am, oh, phew, but I have also repeated fillet all over those 8 additional parts of my shape. Okay? And this is why it is important to understand that there are patterns in Inventor, but it is a lot better to use them into the 3D model rather than using those that you find into the sketch. There is also rectangular pattern. So let me delete. I'm so sad to delete it because it was looking great, but it's okay. So let me delete everything. And what is a rectangular pattern? It's basically this. Look, let's say I make a box. Nothing fancy. And in this box, I want a lot of holes. But not holes that I can just make with hole, because maybe they have a certain shape. So I create a sketch. Again, I make a polygon. This time an hexagon, but not for, just because, to try different things. And I make this hexagon shape in here. I click finish, and I will extrude this one. That can be positive, can be negative, it doesn't really matter. But if I want more of these, what I will do is I select rectangular pattern. I click feature so that I can select the feature that I want to multiply. And then I need to pick direction 1 and 2. So I've made this simple box first, simply because in this way I can pick this edge as direction 1. I can pick this edge as direction 2. And don't worry if it is going on the direction that you were not expecting, because when you pick the direction, you can, first of all, this button is called flip. So you can always flip the orientation according to the direction. So I will do this in this case. But you can also use your direction to be used as a symmetry axis. So you can have that your duplicates will go in both directions, but in this case it's not useful at all. And once that you make your pattern, what you have to do is you need to select the number of duplicates that you want. Let's say I want 4 along this length, and I want 3 along that direction. But you can see also that they are very far from each other, and they are so far that they are going outside my box. So I can, for example, decrease the distance that is in between each of my objects. Let's say I will type 5 in here. But I can also, and you can see this, if I make 5 now, I can see that, yes, this starts at a certain point and it finishes here. But I don't really know how long this thing was. So another way to use the rectangular is instead of spacing, I specify curve length, and I have to pick this one. Sorry, not curve length, I would say distance. And I specify the distance between the first and the last one. So let's say I will make it, I should read how long it was. I think it was about 24. No, it was 22. It was 22. And inside this 22, I can have as many duplicates that I want. So instead of changing the spacing in between, I know the distance between the first and the last, and Inventor will equally space all additional duplicates. Let's say 5. Same thing can be done on the opposite direction. So I can have the spacing, and that is here, and I can always choose just the space in between each of them, or even here I can use distance, and I will it was 17, no, 12, no, 13, exactly. It was 13, and then inside these I can have as many duplicates that I need. Okay? I click OK, and I have all my duplicates created. And I have this extrusion and this extrusion. And what is great is that, see this, if I change this extrusion and I click OK, boom! My pattern is immediately updated. As well as if I change my mind and I say, you know what, instead of going up, I want them to go down and I want them to cut, I update the extrusion, boom, and I update also final result. What is important is that direction that I have selected were perpendicular, but you are not limited in being perpendicular. So if instead of a box I had a shape that has lines that are not 90 degrees angled, it will work the same. Okay? Till here? About rectangular pattern? Yes? No? Maybe? Because now I have to show you something that is believable. Perfect. I love also the depth of your answers. No, like, is it? Yes. Just yes. Okay. And it's okay. Let's see this. Let's see something more that I want to show you into Loft tool, because we have seen Loft and I showed you that Loft is a tool that allows you to combine multiple shapes together. But what is interesting is that you can even have a much more control into Loft by creating guidelines. What it means? See this. Let's see this. Okay. First of all, I will make a very simple one by making two planes. So I will make one shape on an horizontal plane, another shape on another horizontal plane, but just offset from starting one. And I will show you two different results. So first, let me create this offset here. Okay. So I have these two planes. Okay. Let's say 10 millimeters as an offset. So it was this one. I can also make it visible just to show you. I have these two planes. And I want also to make this plane visible, just to let you understand what I'm going to do. Look, in this lower plane, I will start by making a simple sketch. And to make it even easier, I will keep my line open, so even if I make a surface, it doesn't matter, but we will avoid having problems that sketch doesn't work and whatsoever. But I will make this shape here. Then I will select my upper parallel plane. I will make another sketch. I will start also from the axis like this. Okay. And I finish the sketch. So I have nothing really special in here. I just have two sketches in two planes, and I know that I can use loft by click to add. I will make a surface, just because it is faster, and I will click this and that. But you can clearly see that because my shapes are created in two parallel planes, the connection that happens in between them will be basically a straight connection. So if I click OK and let me hide for a second all these planes, the thing that I obtain will be just a perpendicular surface that is just wavy, and it connects top and bottom open lines. Okay, so nothing really exciting. So what we can do more? I delete these. I don't want to delete my sketches. I just want to delete the feature because I will reuse those sketches, and I just want to use this plane in here. That is a perpendicular plane to my shapes. I will create a sketch in here, and it can be whatever, but for example, I will create this spline in here. I will create, finish, I will create another sketch on the same vertical plane, but it has to be another sketch. Can be straight, can be an arc, for example. And if I can't snap it first, I will project this geometry and this geometry so that I simply create two. They are very hard to be seen, but I create 2 points, and then I will snap my arc in here, and I finish the sketch. I hope that this was precise. I don't know, but let's see this. So what I will do now is I will use loft again, and I will do something unbelievable. That is, I will click to add, and I will add this and this again as sketches, and you can see that the result is going to look like exactly like before. There are just two sections, and they are giving me this straight result. What I will do instead is I will add rails. So I will click rail here, and I will choose this one, and it is not precise, I knew it, and I will use this one as well, but unfortunately no, I knew that this it's so annoying when it happens. So let me quickly check if that is fine. So this, I click rail and I select this one, and this works because, sorry, that wasn't snapping. So I just do it again quickly. I make a sketch, but I project this point and this point so that I can snap my spline. Exactly. Okay. So sorry. Again, I select these two profiles, but I click and I add this rail, and I add on the other side, I add this rail too. So basically I have 4 lines that are creating a more complex and organic shape. I click OK, and I will have this great looking surface that I can turn later on into a solid, because I can select it. I can use thicken, and maybe I will use 1 millimeter, but from the other side. Exactly. Even if it's a little bit too thick, but I click OK, and I have created this very complex solid by using 4 curves for loft. Technically, if I am precise, I can have as many profile curves as many rail curves that I want. I just need to be a little bit precise in snapping points, because if not, as you have seen, this feature won't properly work. So if I show you another but very but visible result, see this. Okay, I have this plane, and look, I make a sketch, I make a simple arc, no, I make a circle from the center. Perfect. And then I make a line so that I can trim it. Now what I want to do is I want to have same exact circle on my parallel plane. So I start a new sketch in this other plane, and I don't want to redraw it, so I will click Project Geometry, and I finish the sketch, and I have these 2 beautiful arcs in both of my parallel planes. If I want to make a rail, I need to be sure that I work on a plane that is intersecting my rails on my shapes. So, for example, I will make a plane that is parallel, let's say, to this one, but is passing through a point, so I will pick this vertex. In this way, this additional plane that I have created for sure will touch this point and this point. So I can make another rail on this new working plane. I want to make another arc, but I want to snap it to these two vertices, so I project this point and this point so that I can use them. And for example, I will make another arc like this. And now I just hide this plane. So look what you have. You have two sections, one rail. Look, you use loft. You add sections and you click this and that. But they are one is the projection of the other, so their connection will be perfectly straight. But I've created this unbelievable shape, so I can use this as a rail. And in this way, instead of having just like a cylindrical shape, I have that my circles, my arcs, are connecting each other by also having this curvy path. I will then, I don't know, just to make them more visible, I will turn them into a solid by using thicken. Click OK, and this is the result that I have. I can also hide the surface. And I have this solid that is curvy all over its surface, plus it is curvy here. Okay? Yes? No? Probably? Because now I want to show you, it's pretty tough, but I want to try showing you a feature that takes a while to be managed, but thank you for the feedback, but it is unbelievable. That is a feature that is called 3D sketch. And you're scared now about just saying yes, is it true? So let me show you this additional feature that is a 3D sketch, because this is something very complex and it really depends on case to case, but it is too cool, so I need to show you. So let's see this. Now I have this phenomenal shape. I have this phenomenal shape and I want to use, do you remember we have seen sweep, for example, last week? That is this, no? It is the possibility that we have to create a path, to add a section, and the section will follow the path. But what I want to do now is something that is a lot more complex than just creating a path and making a shape, because I want to make a path that will stay all along this object here. And I need to create a path that is not planar, because my shape is not planar anymore. It is curvy like that. It is curvy like this. So I can just select it and make a sketch, because this is not a plane. But what I can do instead is this. Look. I will show this surface again. And I can instead, what is here, I can make another surface. So I will make something like a spline. I mean, it's not mandatory to make a spline. I make a spline just because it looks more complex. But I will extrude this spline. And it has to be a surface. So I extrude this one. And I will see that this surface and the one that I have used as creation of my loft, they are intersecting each other. So I will click OK. And I have now that surface over my solid, you can see it in orange, plus this second surface. So check this, because instead of clicking to this sketch directly, what I will do will be, I will click Start a 3D sketch that has just a few tools, but what is interesting is that I can create a 3D sketch, for example, by using these tools here that are extremely powerful. So I will click a intersection curve. So I select geometry 1 and then I select geometry 2. That is my second surface. This one. I click OK. Boom! And Inventor will create this yellow shape that is a sketch. So it is something that can be used in multiple ways. One of these will be I can use it for sweep. So I finish the sketch, and only to remove unwanted things that I can't delete, I will just hide. So I remove the visibility from these two surfaces, but just to show you what I have created as a 3D sketch. Okay? So, if I want to make sweep, now I just make a circle on, should be fine if I make it here. Let's see. So I make a circle by using a 2D sketch. Let's say I make a circle here. Should be fine. Let's see. So now, I don't know why it took this line, so let me delete it. Okay. So I use sweep, and the software finds immediately the profile. I have to click the path. That would be this one, and boom, you will see that my circle will follow that phenomenal path that I have created. If I click OK, this will be a union, so I will add this as an element. But if I double click and I make it as a cut, this will remove that beautiful shape from my surface. Okay? And this is one way to start using 3D sketches. So you can create 3D sketches that are coming from intersections of surfaces or from faces in general. But let's delete this one. No! No, this is a disaster. No. Inventor that crashes. No. No. When I will save this on YouTube, I have to edit this part. I have to cut it to avoid people seeing that even Inventor in Marco's laptop can crash. No, what a big failure. Anyway, let's continue with 3D sketch, because see this. Another thing that you can do with 3D sketch, so I have that beautiful thing. Let me do it. Let me see this. Another way instead that you have to create 3D sketches is you can use 2D sketches and you can project them on your created solid. I'm using rotation solids just because they have no flat faces that will make basically the 3D sketch completely unuseful, because if you have flat faces you can just click flat faces and draw 2D sketches. But see this. What you can do is, for example, you can draw something into a plane that is offset from this one, and I will draw into this sketch, I will draw a circle. And wait a second, because okay, see this. I can, for example, draw this sketch. There is a 2D sketch, but ready for this? Look, I can go to 3D sketch, and another way to use 3D sketch is, instead of using only intersection curve, I can use project to surface. So I click project to surface. I have to click faces, that in this case is my sphere. I have to choose which curves I want to project on my sphere, and I will select the circle. And you can see that it will perfectly find the perpendicular orientation, that is the normal direction of my plane. Ready for this? I click apply, and my circle will be projected on my spherical face. not my, I mean this spherical face. And this is the result. What is great in using this feature is that in this way, the shape that you have created and the original 2D sketch are always linked together. So, if you select your original 2D sketch and, for example, you change the radius of this circle, you make it 20, and maybe you move it and you also move, yes, from here to there, your projected sketch keeps adjusting its shape according to your original 2D sketch. And you can use again this shape as you want. I've just made, so let me hide this and that. I have made this time a closed sketch simply because, for example, you can use this in order to split your sphere. So you can click split, you can select split tool, your 3D sketch, and faces, this face, and you click apply. At the very beginning, it looks like you haven't done anything in particular, but by using splitting face, now your sphere has this face working in a certain way and this face being completely independent. So, for example, do you remember we have seen shell? I can select shell, I can click remove face, and shell. Shell these. I should be able to remove. Exactly. I should uncheck face chain. Wait a second. Shell. Exactly. Click before remove automatic face chain because I want to remove this face. Now that I have split, I set thickness of my sphere. I will click OK. Poof! And I have this as a final result. Or I can use thicken, so I can do the same thing. Look, I will just make another sketch on this plane. Also, I'm making circles just because it is faster, but I make another 3D sketch by projecting on this face this curve, and I click apply. Finish the sketch. So now I can use this other shape to split. So I click split. Split tool is this. Split face. Face is that. Apply. And now, okay, I can close it. And now this is another face. Instead of using shell, I can use maybe thicken. So I can click thicken. Even here, I will choose remove automatic so that I can select only this face. And in this way, I will extrude only that split face that I have created before. And I can start working with 3D sketch to make very complex elements. 3D sketch is not finished. There are a lot more things that I want to explain, but I think for today it can be enough. Next week I will continue with the phenomenal explanation of the phenomenal tool that is 3D sketch. For now, I would like to stop here, so let me know if you have a question, because if not, I will stop here. I would like you during this week to upload all of your mood boards and send me just a message like Theodoros did to confirm that you have uploaded your mood boards, so that during this week I will check them, and next week not only I will continue with 3D sketch, but I would like to see if I can explain things related to something useful for your final projects. Okay? Yes? No? Maybe? Okay. So, perfect. So, for now, I will stop the streaming here, and we will see next week, Thursday. Okay? Bye, everyone.